the final time, here we are going over 64, your last lesson, last objective forever. And we started this yesterday, and what we're doing is we're looking at the relationship of lengths inside or outside of the circle. So we're talking about chords and their lengths. We're talking about the lengths of pieces of segments, or of chords and secants and tangents. Folks, yesterday we talked about what happens when you have two chords that intersect inside of a circle, okay? And we talked about a part-part relationship, right? If this is A, B, C, D, and E, the relationship that we came up with was that the product of AE and EC. So if you look at chord AC going through the circle, the part AE times the part EC is equal to the product of DE and EB. If you look at chord DB, again, it's the part that is DE and the part that is EB. And if my memory serves me correctly, yesterday I labeled this a 12, labeled this a 9, labeled this a 3. We were solving for X.
No, other way around. And that was a 4.
4.
Good
solving
try.
for X.
Good
Okay.
try.
No.
The bottom was
X was 4. We were solving.
This was a 4. There we go. This was our X. There we are. All right.
There you go.
And so, following our part-part relationship here, AE, our value for X, times the length of EC, which is 12. We set that equal to the length of DE, which is 4, times the length of EB, which is 9. And recognizing that 4 times 9 is 36, we're looking for what value for X makes that times 12, 36, and that's where we got X equals 3. All right? And that yesterday is where we left off. Okay, that part relationship with chords.
Yeah, it equals.
Are there any follow-up questions on this before we move on?
Yeah, how did you? Wait, is that always the theorem?
When you have two chords that intersect in a circle, this is always the theorem you can use to find their lengths.
I know, but is it always going to be AE and times EC?
They could be different letters, but that's why we kind of want to think of part times part equals part times part. Okay? Yeah. Quickly. Can X and DE be the same? Potentially. Okay. It's not in this case. Okay. Next one. Looking at secants. What are secants again? How do they differ from chords?
They go through line that
goes. Not necessarily through the middle. That's a diameter.
don't stop on the circle.
A secant is a line that passes through the circle.
SRO.
Okay. Kylie, Claire, talk to you once all ready. Kylie, quiet. What's that?
Yes, you will.
I wasn't talking.
Never are. All right. So if we have a secant, two of them that start outside the circle and pass through. Okay. This one's a little bit tricky because we just got off of that part relationship here. We call this A, we'll call this B, we'll call this C, D, and E. The relationship here, and notice we have kind of like an outside and an inside piece here, right? We have the part of the secant that's outside the circle and the part of the secant that's inside the circle. It's not going to be part times part. This is going to be part times whole.
What's the last one?
The last one was part times part, right? The one part of the chord times the other part of the chord. This is the part times the whole. So the secant AD here, the relationship is going to be AB, that outside part, times the whole thing. The common mistake is that folks take outside part times inside part, but it's the outside part, the AB times the whole thing, times AD. Okay?
Oh.
So it's the outside part times the whole
Why did
thing.
you highlight AC?
Because that is equal to the outside part of our second secant, AC, times, again, the whole thing. So it's a part times whole relationship here. And so if we assign these values, let's go 4 and 5 and 3 and solving for x. Question?
Oh, no.
Okay.
Wait. Hold your horses.
Horses help.
It can be a decimal.
Why would you get a decimal? Are you thinking 3 times what number makes 20?
Yeah.
And that's that common mistake. It's not part times part. It's part times whole, right?
Wait,
that
wait.
AB is 4, but the whole
Nine.
secant,
It's 20.
the whole secant is 9.
Yeah.
Okay?
Why?
Don't fall in the trap of part times part.
I get it.
Okay? It's part times the whole thing.
Wait.
9.
How do we know that's just the part? Why couldn't 5 be the part?
5 is a part, but it's part of the inside. It's the
And
inside
it's
part of the
inside.
circle.
Add 12, but it's
Okay.
12.
Joey, Rowan,
Eh.
I've talked to each of you once already. Okay? So it's a part times whole relationship, and that's equal to AC, the outside part of the second segment, again, times the whole thing.
So 3x.
So 3 plus x.
Whoa.
I told you.
Why won't
Okay.
you just 3?
Because this distance, if the outside part is 3 and the inside part is x together, the whole segment is going to be 3 plus whatever the x is.
Okay.
Okay?
So I get that. So 36, but then how would you solve for x?
Okay? How would you solve for x?
Distribute.
Distribute. Okay?
Yeah.
The left side equals 36. The right side, you distribute in that 3 to both terms inside of our parentheses, and we get 9 plus 3x. If you want to rewrite that as 3x plus 9, that's okay. Now you got a 2-step equation to solve here, right? Subtract 9 from both sides. 27 equals 3x. Divide both sides by 3, and x equals 9.
I get it.
X equals 9.
But as many of you did, and I still do it too from time to time, I'm not paying close attention here. It's not part times part. It's part times the whole thing.
Yes.
Especially when dealing with variables, okay? It's very easy to think about this as 3 times 3x, right? To multiply the 3 and x together, but it is 3 plus x because you're adding that outside part plus the inside part, okay? So you have 2 secants. You've got a part times whole relationship then. A secant does keep going, but if it keeps going forever, it doesn't have a length. What makes this a secant is that it starts outside the circle and then passes through to the other side of the circle. Okay? A chord is completely contained inside of the circle. Correct, but they don't intersect, so you don't have a part and part. So you couldn't use that formula to find the length. You have to use something else. Okay? Alex. It'd be x times x plus 3. So no, it would not be the same thing.
Oh, it could be actually.
Vince.
Is the test tomorrow?
No, Vince. Practice test tomorrow. Real test Thursday, Friday. Okay. All right. Next ones. The secants and tangents. So in this case, we've got one secant starting on the outside of the circle and going through it, and that is intersecting with a tangent, which starts outside the circle and stops on the circle. So we have a secant starting on the outside, passing through, and we have a tangent that's going to stop on the circle. Okay? Again, we'll label A, B, C. We'll call this point D. And like with the secants that we saw in the previous example, it's a part times whole relationship. So for the secant, it's again going to be part times the whole.
No.
But a tangent doesn't really have a part. right? The entire thing is on the outside of the circle. So for the tangent, it's going to be the whole thing squared. Okay? The whole thing squared. Using the segment lengths here, AB is our part, not times BC, but times AC,
I have a
right?
quick question for you.
Just a second. And then our tangent line is AD, and whatever value that is, that's going to be squared. So AB times AC is going to be equal to AD squared. Yes, Damien.
How do we know which values are on each side? Because before it didn't really matter, but now it matters. Like, how do we know it could be B? Because on this one there's only one. There's not like AC. It could be AB squared because there's a C.
Right, because this is clearly a secant, and this is the tangent.
What's the difference?
The difference is the secant goes inside the circle, passes through the circle.
And so.
The tangent touches one point on the outside of the circle.
Oh, okay. So on my nose, I'm gonna write tangent.
Sure. And that's why it's called the secants and tangents theorem, because you have one secant and one tangent. Yes. Yes, anything from these, it's all part of the key point. Everything from here can go on a help sheet, including the examples that we plugged in. Okay? The homework section, next up, that can't. But anything from this page, they're all key points. They can all go on a help sheet. Alexis.
Can we just take this page off of our library?
You have to rewrite it yourself.
Oh.
Okay? So, an example.
What do you put in that word?
Let's say this is 16, x, and 8.
Wait, Mr. Jones.
Okay? So, using our formula here, AB is x, and we're multiplying that by AC, which is x plus 8. And that does need to be in parentheses because that represents the length of that segment. We're multiplying everything, that entire x plus 8 by x.
Yeah, what?
Yeah.
Oh, because it's a whole.
Yes, it's the whole. It's not x times 8. It's x times x plus 8. And that's equal to the tangent squared, 16 squared, which is 256. Okay? Yes.
No, you gave me a calculator, but I haven't figured it out yet.
So when we talk about the part whole, the part is the outside part. Okay? Because secants are kind of special. They differ from chords. They have an outside part. And so the part is referring to the outside. Yeah.
Can the part also be the 8?
No, the part, when we talk about parts, it's always the outside part. Okay? Always the outside part. Yeah.
Okay, so I have two quick questions for you. Since when did Andrew sit there?
Damien, I want you to focus on what's going on here.
Okay, and the other question is, can we click down that little turtle?
Not yet.
Not yet.
Okay. How we're going to solve this now, like before, we need to distribute that x into the parentheses. But what do we get when we distribute that x? We get an x squared term, which means if we were to graph this equation, what would it look like on the coordinate plane? A parabola, which means when we say solve a parabola, solve for x, how many potential solutions are we looking for? You could have 2 of them. How do you solve a parabola?
I don't remember.
Well done, Catherine. Okay?
I know.
Yes, that's a point on
So-
I feel that. So excited.
So quadratic.
I'm so ready to do this.
So
That's the only reason I knew.
we are going to have to move that 256 over to the other side. We can make this quadratic formula ready. I told you earlier in the unit you would need to know the quadratic formula for the test. We're going to go over it now so you remember it. Okay. First step, your equation must equal 0. And then you look for your A, your B, and your C. Your A term is 1. Your B term is 8. Your C term is negative 256. It's 1 because there's no number written, it means you have one of them. It's not zero. If there was zero, we wouldn't have the x squared term at all. But an x by itself means there's one of them there. Okay? And then if you forgot what the quadratic formula is, negative b plus or minus the square root
Oh, no.
of b squared minus 2ac,
Cheating.
I was cheating.
all divided by
I
2a.
memorized it.
If you don't have it memorized, put it on a help sheet, please.
Probably read it from me.
Right?
I didn't even know that was there.
You were looking at the whole time.
I'm blind. I'm 40%.
Folks,
Our bills is like 6 times.
now plugging in the pieces here, our b value is 8, so negative 8 plus or minus the square root of 8 squared minus 4 times 1 times negative 256, all divided by 2 times 1. So, good question. How do you solve this? So your calculators, with the exception of maybe Rowan's, they don't have a plus minus symbol, and if it does, he doesn't know how to find it anyway. But they don't have that plus minus symbol. So we do have to solve this in 2 separate equations. So if you remember, our first step, we are going to just do what's under the root, called the discriminant, right? And then we might as well do the denominator too, because that's easy. It's just 2 times x. Okay. So what is
32.9.
what is 8 squared minus 4 times 1 times negative 256?
132.
Well, don't give me the root yet. Give me what the actual value is. 1088. Okay. And we're dividing that by 2. Don't forget about that denominator. You took the root of it. I asked for the value before you take the root. Okay. Now you take the root of 1088, and Ellen's got that value for us. 32.98. Okay. And so we get negative 8 plus or minus 32.98 divided by 2. Now, where do our values come from? Where do our x-intercepts come from here? Our values for x. How do we convert that into solutions?
Yeah, so basically,
Because you don't have the plus minus key, here's where you separate it into 2 different equations. One with plus, the other with minus.
Yes.
So your first solution will be negative 8 plus 32.98 divided by 2. And your second one will be negative 8 minus 32.98 divided by 2. And when you put this in your calculator, remember, don't just do this. Negative 8 plus 32.98 divided by 2, because what is your calculator going to do first? Divide by 2. You want it to add first. So if you do that, put it into parentheses. Okay? What do you come up with? What is negative 8 plus 32.98 divided by 2? 12 point what? 12.49, if you round. And what is negative 8 minus 32.98 divided by 2? Negative 20.49. Which answer is extraneous?
What's 12 plus the negative one?
The negative one. Why is the negative answer extraneous? Because you can't have.
Can you use it in a, so that means you do that all for nothing.
Damien, this is your last chance. Can you survive the last 11 minutes of your St. Vincent career in math lessons? Time will tell. Extraneous means it's an answer that mathematically works out, but contextually doesn't. X cannot be negative 20.49 because X cannot be a negative value. It's a length. Length can't be negative, right? So even though we do get 2 solutions here, only one of them works, and that's the 12.49. Okay? This last unit is very algebra heavy. You need to know the quadratic formula. You may remember things like factoring, those other solving a square root equation, things like that. We've got some to practice with. We've got 10 minutes left to go through as many as we can. But these types of questions are what you can expect on the test Thursday and Friday. You can write the quadratic formula on. Oh, did you write it down earlier?
Wait,
Oh,
was that the last one?
What's the remember the relationship between the two?
Wait, so are we not doing the last one?
hold up.
Thank you. They're really nice questions.
Well, there's 20 choices.
There's the quadratic formula. If you didn't get it down before, there it is.
So I can see.
Then that last one, we already covered this theorem back in theorem 10.2. What is the relationship between two tangents? An example, I'll just erase my extraneous solution work here. An example would be if you had a circle and two tangents. What's the relationship between the lengths of those two segments? Arlene? They're congruent. AB is congruent to AC. So we've already covered that. Just someone says, well, what if you have two tangents? Well, we already talked about it. That would be what happens when you have two tangents. They are congruent. Okay? Woo! There you go. Anything else with the notes before we do some practice problems? Yeah.
So remember the relationship
yeah.
between
Wait, what if?
They're congruent. Two tangents are congruent. What's that?
What if one of them instead of
Like this? Well, if it stops here, it's not a tangent.
Oh, yeah.
Okay. Technically, it's got to be able to continue on. We're just stopping here so we can get the line. A tangent can't stop here because then it would become a secant. Okay. A tangent line, what it has to be able to do is continue on and stay outside the circle. This would not be a tangent because it can't go further without passing through the circle. Okay. All right. Any of the ones on the second page you want to go over? You've got 9 of them to do.
the second to last one.
Second to last one.
Aiden, second to last one.
Last one.
That's a good choice. Shh, 3, 2, 1, you're quiet. So, as with any other situation where you just have things to, a diagram, figure out what you have. Do you have 2 chords? Do you have 2 secants? Do you have a tangent and a secant? Do you have a tangent and a tangent? What is this picture of? 2 secants. So then you flip back to your theorem page and you say, okay, what's the relationship of 2 secants? Which picture looks like this?
Got it.
Okay? And then you say, okay, I found the picture. What's the relationship? The relationship is part times whole equals part times whole. Right? So the whole here, or the part times whole, we've got 4 times 9. Not 4 times 5, that'd be part times part. 4 times whole is 4 times 9. And that's equal to the part of our second secant on the outside, x minus 2, times,
Isn't it 2x?
what's the whole thing? So, okay, so folks, people are saying the right thing, they're saying the wrong thing, they're saying they don't know, okay? When you've got the secant, right, it's the outside part times the whole thing. So x minus 2 is that outside part. The whole thing is represented by x minus 2 plus x plus 4, which simplifies to be, as Ellen said, 2x plus 2. Okay? Yeah, Catherine. Yep. So when you have 2 secants, the relationship is part times whole equals part times whole. The top one, the outside part is 4 and 9. Here, we've got x minus 2, and then the inside section is x plus 4. So the part is x minus 2, and then the whole thing is x minus 2 plus x plus 4. And that simplifies to be 2x plus 2. Arlene?
Does that mean we have to do
Yes! It also means you need to remember foil or boxing. Usually that gets applied.
Wait, what if we just give it another way without doing that?
Okay. What if what?
What if I just like got it another way without getting that? Just do the answer.
What'd you do?
Well, I just added one and then got the answer and then like plugged in a random number. I like.
The old guess and check.
Well, no, it's right.
Okay, but
I know it's right.
okay. And so you said you added one and then plugged in a number and it was right?
No, well, I knew it was that number because I used it on one.
What's the number?
And then I tried it on the other and it was.
So you're
correct.
So you guess and check.
Because it was the same number that we used for the example.
Oh, well, on a test, you're not going to be able to have that
But still,
luxury.
it's right.
Well, good. But on a test, you're not going to have that
I just
luxury.
remembered it from the table.
So, simplify. We've got 3 minutes left, so let's look it down. 4 times 9 is 36. Foiling, crab clawing, boxing here. We get 2x squared. Negative 4x plus 2x is negative 2x. Negative 2 times 2 is negative 4. We can't factor or quadratic formula this until we get it equal to 0. So when you move that 36 over to the other side, you're going to have to subtract it. Negative 4 minus 36 is negative 4. Okay? Now actually, this one you don't need to use the quadratic formula with. If you remember how to factor, you can factor. Okay? If you want to stick with the quadratic formula because you don't want to make a decision on what to do, how you factor is you take out the greatest common factor. And you're left with x squared minus x minus 20. Okay?
I failed that one.
I'm just doing guess and check. Is that
But using the quadratic formula, yeah?
is factoring like 2
Joey, that's
Yes.
the one we.
Yes.
I failed that one.
Okay. It was AR6. Those are, yeah, it's AR6. Basically. Okay.
Pass that, baby.
Using the quadratic formula, it would look like this. Negative 2 is a positive 2. Plus or minus the square root of negative 2 squared minus 4 times 2 times negative 40. All divided by 2 times 2.
I'm near short work. I feel like there's more room for error.
Well, yeah, it depends on what you want to do. This ends up to be 2 plus the root of 324 divided by 4. And the root of 324 is 18.
17.78.
Did you put parentheses around your negative 2 when you squared?
No.
Let's go.
Yeah. So I think it's 18. So it's 2 plus or minus 18
That's
over 4. 2 plus 18 divided by 4 equals 5. 2 minus 18 divided by 4 equals negative 4.
Why am I getting?
Oh, I didn't put it.
Wait, I have 320.
Yeah.
Right, but then the root of that, the root of 324 is 18.
That's why I got the other one wrong. I didn't read it.
So x is 5.
I got 160.
Check your
Good old guess and check.
work there. Okay?
No.
Yeah.
No.
So continuing factoring, at this point, you take what 2 numbers multiplied equal negative 20, and those same 2 numbers add to be negative 1. Equal that up. Okay. We're out of time. If you give me the satisfaction of one more, that's how you math. Thank you. That was meaningful.
How about this?